Okay, so let me discuss some fundamental doubts and questions from my side. Also, I will give few questions. Then I will take your doubts also. Okay, so let us take this question. There is a question here. Question number 66. It is okay. Let me take it as one. So here a block of mass. There is a block of mass 25 kg. This block of 25 kg is pulled along a horizontal surface. So this is a horizontal surface and you are pulling it along, but the force is acting in this direction. Okay, force is acting in this direction. This force is making angle 45 degree with the horizontal. The friction coefficient, the coefficient of friction is given 0.25. Okay, and the block travels at so first very important condition is given. Block is moving with a uniform velocity, means its velocity is constant. I think you know what is the meaning of uniform velocity. Uniform velocity means the velocity is constant. So tell me, what will be the acceleration if the velocity is constant? Good evening. Yes. What will be the acceleration if velocity is constant? Zero. Zero. That means it is in equilibrium. That means the net force is zero. You already know that. Okay. So velocity is constant. That means acceleration, which is dv by dt, is going to be zero. That means the net force has to be mass into acceleration. Net force has to be zero. We know already this condition. Okay. Now the question is the work done by the applied force during a displacement of 5 meter. They are saying that there is a displacement of 5 meter happens. 5 meter displacement. We have to calculate work done by applied force. The force applied is constant or not? Is it constant or not? Did they give anything? Force is this, the friction. They have not mentioned anything about force. Whether this force is a constant or not, that you have to decide. That you have to decide whether this force is a constant or not. So we know one thing, that it is in equilibrium, net force is zero. Let us resolve the forces and free body diagram. Do that. Free body diagram. So what are the forces acting on the body? Let us draw free body diagram. Mg, Mg, and normal of course upward. So normal will be like this. Then this force is applied like this, F, and friction will be acting like this. Body is only moving horizontally. Body is always in the contact with the surface. Okay, that is what we are assuming. So we can resolve, right, because this angle is 45 degree. So we can resolve this force. So this will be F cos 45 degree and this will be F sin 45 degree. Right? We know that these are the forces. So now we know that it is balanced, means horizontal forces must balance, vertical forces must balance. Let us balance this. Let us balance vertical forces. So normal plus, we need to calculate work. We'll do that. First balance forces. So normal plus F sine 45 degree. Normal plus F sine 45 degree is balancing what? It is balancing mg and F cos 45 degree. F cos 45 degree is balancing friction. Okay, this is what we know, right? Okay, so now we can try to first of all find out this friction. Friction already we know, mu time normal. So from first equation normal we can calculate. What will be normal? Mg minus F sine 45 degree. Okay, so this is normal. Let us substitute here in this formula for friction. So F cos 45 degree is friction is mu times normal. So let us substitute cos 45 1 by root 2. So F by root 2 mu times normal. Normal is mg minus F sine 45 1 by root 2. So F by root 2. So from here try to calculate what is F. What is capital F? So capital F you can definitely calculate. You can open this mu mg minus mu F by root 2 and F by root 2. So from here try to bring one side. So f by root 2 plus mu times f by root 2 is equal to mu mg, right? Now let us take f common, or if you want LCM, take LCM root 2. So f plus mu times f is equal to mu times mg. So from here f I take common 1 plus mu, and this root 2 will go this side, so root 2 mu mg. So from here f is coming as root 2 mu mg divided by 1 plus mu. Now this idea gives the force, and clearly we can see that this force is a constant because mu is constant, m is constant, g is constant. So definitely this is a constant force. Yes, definitely this is a constant force. Any doubt in this? Okay, so force is constant. Now work done. Work done, let us calculate. So work done is dot product of force and displacement. So work done by this force is equal to dot product of force and displacement, and force and displacement is making angle 45 degree, we know that. Okay, so we can write this as magnitude of force, magnitude of displacement, cos 45 degree. Let us try to solve it. So f we already calculated, substitute root 2 mu mg divided by 1 plus mu. Displacement they have given in the question, how much? I think they have given 5 meter. Displacement is 5 meter. Cos 45 1 by root 2. So 1 by root 2 cancel. Now you solve 5 mu mg divided by 1 plus mu. Now we'll substitute the values. Substitute 5 mu value they have given as 0.25, 0.25. Mass value they have given 25, and let us take g. G they have not given, and according to the option 490 is also option. So let us keep 9.8. G you keep as 9.8. Okay, and then 1 plus 0.25. Solve this. This you need to solve. Okay, so let us do this calculation. So this is how much? 100 will come here. Okay, let me write it like this: 5 into 0.25 into 25 into 9.8 divided by 1.25. So definitely I can cancel this by 25 times, right? 25 into 5 times, I think it will go away, right? And this 5 will also go away. So we are getting the answer as 25 into 9.8. Suppose this is 10, so near to 250 it will come. So near to 250, the answer given is near to 245. So we can take, I think, 245 answers. What do we think? Can we take that? 245 we can take. Okay, right? Okay, done. So what was the main doubt? I will also clear that. The doubt was like uh, uh, like friction calculation doubt was there. Mu times normal was calculated, mg minus f sin theta, and then friction was mu times normal. So calculation was problem in the friction only. I think friction is mu times normal, that is correct, right? But f cos theta is equal to friction, right? F cos theta is equal to friction in this case. Are you understanding this? This is hmm, hmm, hmm. Ah, because and cos are same here, right? So might be they have taken that, but the idea is that it is equilibrium. That main idea equilibrium means you have to balance the forces horizontal and vertical. Okay, so you will get this equation and you can solve f. Main idea you wanted to solve f only, right? No? Correct. You have written mu times normal. Normal you have calculated correct only, mg minus this. But after that, what you have done? You have directly tried to substitute. No, I think what you have tried to calculate, you have tried to calculate friction minus this. This is where I think you are making mistake. You are trying to calculate net force in horizontal direction. So you are trying to calculate the friction minus this, that is where mistake is. Are you understanding? Because why should we do friction minus this? Right? Because body is balanced. Although body is moving, but it is moving with a constant velocity. So body is in equilibrium. Okay. So we have to balance the force. So this equation is the main critical equation which you, I think, which you have missed out. This equation, this equation, this equation, right? The horizontal component, I think, if you equate, then you will got, and you have to calculate work done by applied force. Applied force. Are you understanding? You have to calculate work done by applied force F. So that is what we need to calculate F. To calculate F, we have two equations. One by applying the vertical forces balance, one by balancing horizontal force. By these two equations, we can solve F, and F is a constant force. Then work done is dot product of force and displacement. Clear? That's what it is. Done. Clear? Doubts? Hmm. 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 No, 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 no. Applied force. I think you are misunderstanding. Applied force, there are many forces on the body, and net force is the resultant of all the forces. They are not asking work done by net force. You see in the question, they are asking work done by applied force. So, whichever force they are asking work done by, that force you have to take. Okay. You are taking work done by net force. That is what is mistake. Huh? Are you understanding that? So suppose they ask work done by mg. Mg is acting downward. Displacement is horizontal. So work done by mg is 0. If they ask work done by normal, normal is acting perpendicular to displacement. Work done by normal is 0. If they ask work done by friction, friction is acting opposite of displacement. So friction into displacement is cos 180 degree. So minus friction into 5. That's how you will calculate. Right? So, so it depends on what question they are asking. They are asking work done by individual force. They are not asking work done by the resultant force. Work done by resultant force, that means if they ask work done by net force, now what is the logic? Net force itself is 0. Net force itself is 0. So there is no work done by resultant force. Resultant force is not doing any work here because work done by net force is 0. Are you understanding this? Yes? Hmm. Okay, done. Then any other conceptual doubt, if you have, definitely you can ask. This question has to, this class is for that purpose only, asking clearing doubts. Hmm. Hmm. One question Raghu has sent, 1 minute I'll take. Which question? Number 10. Okay, question number 10 I will take. Question number 10. And question number 9 also I wanted to share with question number, okay, 10 only. That question only I wanted to share, yes. The same question I wanted to share because today one student asked about that. Okay, this question I want to share first. Question number 10. Let me explain what this question is. So the question is like there is a this kind of a structure is there. The tube is there, and in this tube the surface is smooth. So there is like a ring, a chain is there, chain, and this chain is being suspended like this. This chain is there, and this is the ground here. This is the ground like this. Okay, I think somebody is joining. Yeah, Raghavan. Yes, the question is there. Ask. Static friction. Okay, we will discuss that. Okay, whatever doubt is there. Hmm. Hmm. Static friction. Yes, friction can do both positive and negative depending on how friction is working. Okay, friction can do both positive and negative work. Because suppose two blocks are moving together, then friction is moving the upper block and displacement is also in the same direction. So friction is doing positive work. Okay, static friction only, that is right. Okay. Right. So first, this question is an interesting question. Note about this question. This question is saying that a chain AB. There is a chain here. This chain I am calling it AB. This chain, and this chain is smooth surface. All the surfaces are smooth, and this portion is height h. This height is h. Okay, and then this point is A and this point is B, okay, and height is fixed. Now what is happening is that at a certain moment the chain A is set free. So you release this chain, so this starts falling. This starts moving like this. It will start moving downward. Okay. The question is that what is the velocity of int A of chain when it slips out of the tube? When it is going to slip out of this horizontal tube, there are two sections of this tube. One is this horizontal tube, this portion. This is the entire tube only. This hole is like a tube only, but the horizontal portion is the portion on which this some portion of this chain is kept. The vertical portion is a constant portion. Okay, so what happens if this chain starts sliding? So let us say at any instant, if this chain starts sliding at any instant, chain starts sliding like this way, and chain will also start because now there is a lot of assumptions in this question which you have to be make very clear, otherwise there will be doubts in this question. Okay, so this is the tube like this, and this is the ground here. This is the ground. Okay, and this is the tube. Now this I have taken at any instant. Okay, at any instant I have taken this. Okay, and this point is A and this point is B. Okay. Okay, so I am taking that once it is released, this chain is released. As this chain is released, this starts moving downward. Note that whole chain moves, but this portion always remains constant. But what is happening to the portion at the bottom? So it may start depositing here. Okay, it may start depositing here. Depositing here means it starts becoming on the ground. Are you understanding this concept? What is that? Try to understand this. Okay, this is the chain. See, right now this is the chain. This is the chain, and total. This is the total length of the chain. Total length may be something. Okay, total length may be something. I think total length is given as L. Okay, so suppose if I take total length as L, so this length will be definitely L minus H because total length is L. So this is L minus H and this is H. Okay. So, so what happens that as you soon as you release this chain, and everywhere no friction is there, smooth surface is there. Okay, smooth surface. So what happens? This chain starts sliding, and after some time or at a given instant of time, you can see it is passing like this way. Chain is falling, and some part which was actually touching here, this last bottom part was touching the ground. Now this bottom part is extending on the ground and it is becoming flat like this. Okay, it is going to lie down on the ground. Now this is the main confusion of this question here. I will explain what is the confusion in this question. So this portion, the point B, if you ask, the point B actually comes here. Okay, the point B is continuously moving. Definitely, it will be moving. I am taking the point B as the last point of this. Okay, but the point on the ground, that is important because chain which is coming in hitting here, that point is on the ground. This point is spreading on the ground. Definitely, this point is spreading on the ground. Remaining part. Question is what? Question is when this point, let us call this corner as point C. This point C is the corner. Okay, this point C is the corner. So when this end A reaches to that corner C, that time what is the speed of the chain? That is the question. Are you clear about the question first? Yes. So total length of the chain is L. Total mass they have not given. Only length they have given, that's all. Length is given and this height is given, that's all. Two things are given, and they are asking that once you release it, it starts falling down. As soon as it starts falling down, once this point A will be crossing this C, then what is the speed of the chain, entire chain? What is the speed of the entire chain? Okay, so let us discuss this question in detail. Very important question is that there was a confusion related to this question. Okay, so first of all, what we can do is, let us consider this part at any instant. Let us say this part length is x. Let us consider this length as x. Initially, the value of x was L minus h. So, initially value was L minus h. Then, how much is x at any instant? At any instant, x is smaller. So, x is definitely decreasing. You should know that x is decreasing, and this was the initial value. Okay, at time 0, you can say. At time 0, the value of x is L minus h, and x is decreasing. At one instant of time, x has to become equal to 0. When x becomes 0, that means there is no part hanging here, means no part lying on this horizontal surface. So all the part will be now down. So x must become 0. At that instant, what is the velocity of the entire chain? That is the question. Initially it was released, so initially velocity will be 0 because it was released. Initially it was released, chain was released, so initial velocity you can take as 0. Final velocity they are asking, and very important point to note that x is decreasing. X is decreasing. So that is what we need to understand. So first I will try to solve basic approach. The basic approach is, let us consider that this portion of the chain which is right now on the table, some length x is there, okay, and the portion which is hanging, some portion is hanging, some portion is again depositing on the ground. Forget about that part, okay. So if I consider this portion, if I consider this entire portion as one mass, and if I consider this portion as another mass, and I may consider this portion as some mass also. Three part we can break down. Okay, first part which is on the tube or horizontal surface of tube. Another part is hanging. Hanging part is always constant. Note that hanging part length always constant. That length is not changing. Okay, so this is x part. This is x part. This length also will be changing because total length is L only. Okay, so let us consider at this point wherever the joining is there, the joining point, okay, the joint between these three parts. Let us call this as first part, and this as second part, and this is third part. Three parts let us break down, okay. And now consider each of this part like a block or a system, okay, a single mass you can consider this part. Let us call this as mass m1, and this part which is hanging you can call this as mass m2. This mass which is further hanging, that mass you can call as mass m3. Okay, this is a better way to analyze this question. Now first of all you should know the masses of each part. First part mass will be how much, because you know mass is proportional to length. So lambda is called linear mass density. First of all you should know what is lambda. Lambda is called mass per unit length. Mass per unit length. Mass per unit length. So unit length has mass lambda. So x length will have mass lambda into x. Similarly, mass m2 will be this length is h. So that will be lambda into h. And this length will be how much? This length you can also tell. Total length is L. L minus h minus x. Correct? Your total length has to be L, right? So sum of all this length must be equal to L. So the mass m3 will be equal to lambda times L minus h minus. Are you clear about the masses? First tell me. Are you clear about the mass? Okay. So now consider that there is a tension here acting. This tension is of course same. Let us call this as tension T1, T1. There may be some tension here, T2, T2, right? Right. And of course this portion, the last portion is again coming back on the ground only, right? It's coming back on the ground. So there may be some normal reaction acting on this because it is contacting the ground. So some normal reaction is acting here. We do not know what is that normal reaction. Okay, right. And what forces will be acting? Also note that this is also on the horizontal surface of this inclined plane. So here also there will be some normal. Let us call this normal as N1. This normal, let us call this as N3 because it is acting on the third bond. Let us call this normal as N3. N3. Now, what other forces are acting on each body? Its weight M1g will be acting. Friction is not there. Here, weight M2g will be acting down. Here, weight M3g will be acting down. Right? These are the things happening. Clear? This is free body diagram. Now, let us study individual body. Note that this portion which has come on the ground, this should not be moving. I hope. I hope the portion which is lying on the ground, that may not be moving. It is just depositing on the ground, right? It is not moving. But what part is moving is second part and first part is like connected parts. They look like, although all parts are connected, but first and second part are more connected. Third part is getting deposited on the ground. But all the three parts are connected. It is not that the chain is breaking after falling on the ground, right? That's not happening. So let us consider acceleration. Let us consider acceleration of each part same because they are connected. Assume that they have same acceleration. What about this acceleration? Uh, this acceleration we do not know because there is no information given of this part. But still, uh, if you say that they also have some acceleration, but I think it should come at rest because as soon as it is coming in contact with ground, it is coming at rest. So you may consider this at rest. Okay, I think you need to consider this because it is depositing on the ground, it is coming at rest. Okay, then let us. It is not like that. It is, yeah, that is what it is. It is like a chain, right? It is not like a completely solid body. It's not like a complete solid body. The chain is also flexible. So chain is connected like no elements are there. No, these are like elements of the chain, right? That's what it is a different case. This is like elements of the chain. Okay. And suppose if you try to release this chain, some portion of this chain will come on the ground. They will be at rest, but other portion will still be moving. It is possible. It is not a rigid body. It is what it is. So chain is not a rigid body. Some part can be moving, other part may not be moving also. That can happen in the chain, and that is what is happening here. The portion which is on the ground, that is, yes, yes. Entire process is happening in that tube. Okay. Right, so this is rest, and these two are moving. We need to calculate their velocity. So let us say that there is acceleration happening, okay, because of the tension force. So let us study the first mass. So if you study first mass, the only force acting is the tension force T1. Anybody know? Yes, Raghu. No, try to understand this. This is made up of elements. Now I told that is what it is made up of, elements. These are made up of elements. As soon as this element comes in contact with the ground, that element comes rest. Other element which has not touched the ground, that is only moving. You try this experiment, take a chain and try to release it. You will find the portion which is coming touching the ground, that is coming rest. Other portion will be moving, although all the portions are connected. Are you understanding this? Hmm. Hmm. Top. Yeah. That is what. That is why this question has lot of confusion is there. how the piling is happening, that also they should give. Piling. Piling is happening like, mountain is forming or horizontally it is getting spread, right? That is what is the main problem. If you consider these two different ways of piling, the calculation will be totally different. Okay. So in this question, uh, yes. You need to assume something, that the portion which is contacting the ground, that is disappearing. You have to assume that is disappearing, means that is not playing any role in the motion now. The portion which is touching the ground, that is completely become stationary. That is what is assumption in this portion. Okay, are you understanding this? That is assumption here. Hmm. Yes, that is what it is. The portion which is touching the ground, after that you don't have to study that. Okay. Okay, so let us draw free body diagram. So first body M1, if you see, the forces acting on this M1 is only this tension T1. This is the net force. So this T1 is equal to mass M1 into acceleration A. Right? That will be the equation for this. So we can write this equation. Okay, then for this mass M2, let us study this mass M2. So the idea which you told, na, disappearing, that is I think the main idea here. They are disappearing by some magic. So here this tension T1 is acting, and as soon as it is disappearing, na, that T2 you have to take zero also. Disappearing means it will not be applying any T2 also. That is what they are making here assumption. Okay, but let us say if you take some T2, let us say you take some T2, and this force is M2G, then you will apply here Newton's law. It is going downward with acceleration. So net force you have to write downward, M2G plus T2, downward force minus upward force T1 is equal to mass M2 into acceleration, right? This is what you have to write. Correct. This is what you have to write. Third part, let us not write because it is coming rest. Now see here, when I add these two equation, this is first equation and this is second equation. Suppose if I add both this equation number 1 and 2, what happens is T1 plus M2G plus T2 minus T1 is M1A plus M2A. Now here what happens is T1 get cancelled. So M2G plus T2 is equal to um, M1 plus M2 into A. Now that is where T2 should, how to consider T2, because if you see the horizontal portion M3, the T2 is acting T2 is acting like this way, but this is not having any horizontal motion, right? But you may again think a little bit deep that its weight M3G is acting, and there is a normal here also acting, this normal M3 which we have written. So T2 has to be balanced with this, right? T2 has to be balanced, but that is what they are not considering. They are considering by magic it is disappearing. So if you consider by magic it disappeared, so T2 will become 0. And if T2 becomes 0, we are assuming T2 to be 0. This is a pure assumption here. This is an assumption that T2 is 0. So if you consider T2 as 0, then M2G plus 0 is equal to M1 plus M2 into A. Now this is the main equation. Now try to solve it. Now we can solve it. So M2G is equal to M1 plus M2 into A. Now let us write M1, M2, the values which we have written there. Mass value is right. M2 was lambda h, right, into G. M1 was lambda times, what was M1? Lambda times x it was, I think, correct? Lambda times x is 1. M2 is lambda times h it is, right? Lambda times h it is into A, correct. So then you take lambda common in this right hand side. So this become x plus h into acceleration lambda h into g. Now lambda get cancelled. This become h into g is equal to x plus h, and this acceleration they are writing in terms of a function of velocity, which they are writing as v dv by dx. right? We can write acceleration as dv by dt or v dv by dx. That is what they are writing. Then you solve it. So v dv becomes equal to, you multiply this side, hg into dx by x plus h. After that you are integrating. So initial velocity is 0, final velocity is v, and here x value initially was L minus x. But here very important thing you have to note that acceleration will be v dv by dx, but because dx is negative, acceleration factor negative will be coming here. This is very important, because x is decreasing. So whenever x decreases, dx would be written as minus dx. That you note. That is going to come in many problems, including advanced portion. Whenever x decreases, you should write dx as minus dx. Okay. So v dv by dx we will write as minus v dv by dx. Are you understanding? This is a very important thing. Okay. So that is a minus sign here. We should note that there is already a minus sign here because of dx. Okay. Right. Then we have to integrate x from L minus x to 0. Remember, we have to take the limit of x. Okay, then do the integration. This integration is v square by 2, and here the limit is 0 to v. Right hand side minus gs come out. Integration of 1 by linear form is ln x plus h comes, and then here the value of x is going from L minus x to 0. L minus, initial value was how much? L minus h was there. Sorry, initial value was L minus h was there. Initial value was L minus h. L minus h to 0 it is coming. Okay, now you substitute it. So v square by 2 here, upper limit, lower limit is 0, minus ch. Substitute upper limit. So log a minus log b, you know, one time I will write. X you substitute 0, so ln h minus ln. Substitute upper lower limit. X you are substituting as L minus h. L minus h plus h will get cancelled here, h. So you will be getting this as v square by 2 minus gh. This becomes ln h by L, right? And this minus will come in the log, so it becomes gh ln L by h. I think you know that the power will reverse the log ratio. Then from here, v square become 2gh will multiply here ln L by h. So from here v comes as root under 2gh ln capital L by h. This is the answer. But again, to understand this solution in the book, they have not given, they have directly write some step and solve it. So that is why it is very important to understand fundamentally what is happening in a question, what is actually happening, the magic that has not given. Right? That is a pure assumption that once it touches the ground, everything disappears there. So you do not have to consider that part itself. Are you understanding this? Yes. The final position at which they are asking calculation is this only. They are asking calculation when this x becomes 0. This x becomes 0 means this portion becomes 0. So total portion will be hanging here h length, and the remaining length will come on the ground. No portion is on the tube, right? Understanding? That is what it is. Okay, then, but this disappearing, taking this value t2 to be 0, and this doesn't look like proper. They must give in the question proper conditions. They have not given. Already I told you piling up is another case. That piling up can be advanced question. Piling up is a very good question. Okay, that I will explain what will happen if this start piling up like this. For example, this chain starts falling, and let us say right now this portion is there. This was L minus h, and this is h. Now let us say it starts piling up. So some portion starts piling. So suppose the first element which was touching the ground, let us say this is first element, second, third, fourth, like that. So as soon as you start moving, let us say this comes to rest, then this comes to rest, then this comes to rest. like that something will happen. But piling also means how piling is happening. So many conditions required, right? So many conditions required. Are they piling it like this way, that way? Are they forming a mountain like this way, like this way? Something they should give in the question clearly what is happening. Okay. So in JEE Advanced, they will properly give the questions. Now, formula you don't have to create, you have to see what is happening there. Like for example, you need to break this element, apply Newton's law. You're taking that segment and then this segment and that segment, and then forces are acting, Newton's law you're applying, automatically calculation will give the result. Okay. So only thing what you need to know is how to apply the law of the concept, right? For that clarity is required. Lot of clarity is required to understand the deeper applications of anything. Okay, that will come gradually. It comes. No, no. If you take the pile-up length, means suppose let's take this question, a simple question you take. Okay, let us take a simple question that this is a chain which is touching the ground, and let's say this length is L. This portion is, let us say, touching the ground right now. This last point is point of contact here. Okay, and you are holding it, so there is no contact, almost no contact, you can say. Somebody is holding it. Now if you release the hand, this starts falling down. As it starts falling down, it will start hitting the ground also, right? It will start hitting, each of the element will start hitting. How they are going to hit, that is also important, because at this each point there may be some joint which may create rotational effect also, right? So there is lot of dynamics will be coming in this question. Each element will be rotating this way, that way, this way, that way, we do not know now, right? It will be quite complex. Suppose this element has rotated like this, then it has come like this. Okay, like suppose one element has come on the ground like this, so this will be touching now the ground. Then after that next element will come, again let us say it is coming again, so this element is definitely moving forward. Chain is at the same position, chain is only falling vertically, but this element 1 2 will be moving this way, this way. So whenever each element is striking there, there is some push is given here. Suppose the third element is now going to deposit, it will be pushing the second element, second will push the first element. So some forces are also happening in between them, right? You cannot say there is no interaction, there is interaction in that. How those interactions will happen, we have to think, it will be a complex case. Okay, we'll think about it. We need to think many case conditions and all that. Okay. Then any other questions? Any other question you have? Anybody having any doubts, questions? Ah, yes, send. Yeah, send in the group. Yes, that's any doubt, question. Any question you have, please share. Which question here, Raghu? Question number 13. The bob of a pendulum is released from horizontal position. So there is a pendulum. This bob is released like this. Okay, this is fixed here. This is horizontal position. It is released. The length of the pendulum is, this is the length of the pendulum. Length is given as 1.5 meters. The speed with which the bomb arrives at the lowest point, given that it dissipates 5% of initial energy again. So some air resistance is also there. So once it reaches here, it will have some speed. This speed we have to calculate. Okay, some mass will be there, mass is not given. But they are saying that 5% energy is lost. 5% energy is lost. So first of all, apply energy conservation, and total energy, there will be loss of energy. So note that initial, let us check that this is the initial level and this is final level. So this distance between this level is L only, right? Suppose if I consider this as reference level, if I take as reference level, so reference level, I can take gravitational potential energy 0, and I am going down now. For down position, here the gravitational potential energy, I have to write as minus mgh. Remember that this height is h is same as the length. This is minus mgl. Okay. Remember, if you go above reference, you have to write plus mgh. You go below reference, you write minus mgh. And initially it was released, so initially there was no kinetic energy. Kinetic energy was 0. Here there will be kinetic energy, which is half mv square. But they are saying that here the total energy. So anyway, what is total energy here? Total energy I am taking 0, right? And here what will be total energy? Here total energy will be sum of this, add them. So kinetic energy plus potential energy, gravitation. So here total energy should be half mv square minus mgl, right? This must be total energy here, correct? Now they are saying that this initial energy and this final energy are not equal because some loss is happening. Some loss is happening. How much loss is happening? 5% loss is happening. Okay, 5% loss is happening. Let us try to balance 5% loss. So that means if 5% loss is happening, the final energy and initial energy are not equal. Correct? Huh? So final energy, if loss happens, means what is loss means? Loss means initial minus final, correct? So total energy initial minus total energy final, that is called loss. Loss of energy, loss of total energy. Loss means initial minus final, okay? And this loss they have given as 5%. 5% they have given. 5% of what? What they have given? 5% of initial energy. But initial energy I am choosing 0. This is what I think mistake is going to happen. Because if you take total initial energy as 0 and 5% of that is 0, then there is no loss, na? No, try to understand. This loss is 5% of initial energy, right? But initial energy itself, if I choose 0, then there will be no loss. So I think in our choice we are making mistake. Are you understanding? This is the logic. If you choose initial energy itself as reference level, because 0 is coming because you have taken reference level 0. So don't take that reference level 0. Now this you are understanding. You should not take reference level 0. Oh, that means I should choose this reference level then. The question is speaking many things. This question is saying don't take that reference level 0. So take this reference level 0. That means here I will write potential energy as 0. Correct. I will choose this as reference level then. Okay. So this level I will choose as reference level and I will write this as 0. So let us take this as reference level. Then their potential energy will be plus mgh. Correct now? Yes. Right. This potential energy will be plus mgh. Now you can solve this question. This you have to write plus mgh. So total energy is not 0 now. Total energy is mgh only, because kinetic is 0 but potential is mgh. So total energy, now you can apply this idea. So here potential energy you have to take as 0 here, right? You have to take 0 because this reference level here. Okay. So now you try to solve it. So total energy initial is mgh. So this is 5% of mgh. 5% of mgh. Yes. Anyone any doubt in this? What? No. If you choose that as reference level, that total energy itself becomes what? Total energy itself becomes 0. So 5% of 0 is 0 only, na? Are you understanding this? 5% of 0 is 0. Second case here. Second case, second case reference level is this one. So here potential energy is 0, their kinetic energy is 0, their potential energy. So total energy is mgh and final total energy is half mv square. Okay. So loss, now calculate loss. Loss is initial minus final. So 5% of initial, 5% of mgh. It's not 100% loss. No. It is not going upward. It is coming from top to bottom. It is coming. Read the question. Initially, no. Reference level is not going up or down. Reference level is for choosing potential energy 0. Reference level is not that motion start from here. Reference level is where you can choose potential energy as 0. Okay, that is what. Okay, so now you try to calculate. Now we will calculate. So total initial energy is mgh, right? Minus total final energy is half mv square. Now you solve it. Now we got the answer. Solve it. So from here, half mv square becomes equal to, this will come here. So mgh minus 5%, that will become 95%. So 95 by 100 it will become mgh. Now mass what cancelled. So v becomes equal to root under 2 into 95 by 100 gh. This you solve now, because they have given all these conditions. So 2 into 95 by 100. If you take g as 10 or 9.8, did they give 10? Not given, so take 9.8. 9.8. And height means the length. The length is given as 1.5. Now you do this calculation. Okay. So try to calculate this. 2 into 95 into 9.8. 9.8, if I remove, 10 will come. 1.5 also I will remove, so 10 will come. And already here is 100. 98 into 2 will become how much? 196. For 196, 14 will come the root. 100 comes out. Now inside the root, we are left with 95 into 15. 95 into 15. How much this will come? 95 into 15. What it is? This you try. 95 can be written as how much? 19 into 5, and this is 3 into 5. So 5 will come, one extra 5 will come. So 14 into 5 by 100 will come. And inside that 19 into 3, nearly 57 will remain inside. Okay. So this becomes how much? 70. Right? 7 by 10 under root 57. This you solve. Nearly how much that will come? Check out this. Under root, nearest root of 57 is 64. 49. Near, it will remain between 7 and 8. Between 7 and 8 it will remain. Right? So the answer will lie between 49 by 10, that means 4.9, between 4.9 and this remain 8, suppose 8 into 7, 56. So answer will be between 4.9 to 5.6. Check the answer. Answer must lie between 4.9 and 5.6. Second option will come there. Correct. You can calculate if you want. Okay. Tell me. Calculation you can do now. What? See, 2 into 95 by 100 was there now. G I have taken 9.8, height is 1. Where? Here. You subtract now. This half mv square come that side. Mgh minus 5 by 100 of mgh. How much it is? You tell me. Mgh minus 5 by 100 of mgh is how much? Then, yes. Yes, tell me doubts. Yeah, only energy can, because they are saying that some forces are acting, right? So that force is causing how much loss, that you should know. How much loss? Suppose 5% is lost, means 95% is remaining, right? Suppose 100 joule was there and 5% loss, then now you have only 95 joule. So that 95 joule is only converting into kinetic energy. 100 joule is not converting into kinetic energy, right? Are you understand? But suppose your question is percentage information is not given, but they have given friction force. That is your question, right? If they have given friction force, then you apply work energy theorem now. Then you apply work energy theorem. Work energy theorem is the best method. So work done by two forces only, mg and friction. Work done by this is change of kinetic energy. Okay. So work done by mg is mgh, that you know, and friction is acting upward and downward. You are going a displacement of h. So this angle is 180 degree. So work done by friction is minus friction into h is equal to change of kinetic energy. So if they have given friction, height you know, mgh you know, you can calculate change of kinetic energy, and initial energy was 0. So final energy is half mv square. Then you will calculate from here mg minus f into h. Then you can calculate speed from here. This will be like a formula you solve. Root under mass you divide it. So 2 by m of mg minus f into h. So mass you take inside, so root under 2 g minus f by m into h. This will be the formula then if there is a constant friction. Okay. Clear? Anyone any doubt? Any other doubt if you have, please ask. No doubt, done. So let us wind up then. Any doubt if you have, you can ask. One question I will, two question I wanted to give from my side. One question you asked, that chain question. Another question I will give today. I discussed that question in the class. It's a good question. So suppose there is an inclined plane and that angle is theta, and there is a block. This block with mass m, this capital M. And this horizontal surface, there is a horizontal surface, and this wedge is moving with a constant velocity. Its velocity is constant. Okay, and this surface is a rough surface because they are asking you to calculate work done. Find work done work done by the friction force on the block in a time interval t. Okay, so you have to calculate work done by friction. So definitely this is the block here. Okay, this is a block and this is a wedge. So as this system is moving, and also this important condition they have given, that block does not slide over the wedge. Block does not slide over the wedge. Block is not sliding, that means both of them are moving together. Together they are moving horizontally with the same speed. Okay, they have given this. Now this question involves a fundamental idea. Okay, so remember, whenever you have to study relative motion, observer should be standing on that frame of reference. Because they have given no relative motion with respect to wedge, means observer should be taken here. The observer should be here, and this observer does not see block moving, because observer and the block together are moving with the same speed. Okay, so that means with respect to this observer, the block is at rest. So when you draw free body diagram, like you draw mg, you draw normal, right, all these forces, when you draw friction, how will you decide here? So to decide friction, first you draw all other forces except friction. You draw all other forces. Friction you decide in the last, because friction direction is a confusing. So friction always you have to decide in the last. Okay, so first you draw forces. Mg is acting, normal is acting, right? And is there any pseudo force? There is no pseudo force. Why? Because this is moving with constant velocity, so its acceleration 0. So because it has 0 acceleration, he will not apply any pseudo force. But suppose if this is under acceleration, he has to apply a pseudo force in this direction. We need to understand this point very clearly. So right now only two forces and one friction we have to take. So these two forces is normal and mg. We will not apply any pseudo force because this is not under acceleration. Right. So now you decide which direction friction should act, because this has to be in equilibrium, because he does not see it moving. So friction definitely has to act in this way to cancel the component of mg. Why? Because mg component, mg sin theta, will act this way. So friction has to act opposite of that mg sin theta. Clear? Are you clear about this? Yes? Okay, so that is how, yes, that is how friction will act. So friction will act like this way. Mg component is, this is mg sin theta, you know that, and this is mg cos theta will be acting, and normal will be acting like this. So normal balances mg cos theta, we know that, and here friction has to balance mg sin theta. Friction has to balance mg sin theta. So now let us try to calculate work done. So work done by friction, work done by, yeah, friction only. So friction is acting this way, and displacement, remember displacement is happening like this way, and body is moving with a constant speed. So this displacement is velocity into time, that is displacement. And note that the angle theta is this angle theta, because this is the inclined plane parallel. So this becomes 180 minus theta. So angle between force and displacement is 180 minus theta, and friction is a constant force because mg sin theta is constant. So dot product of friction and displacement you have to take. So friction is mg sin theta. So you can write first, it's like a friction into displacement into cos of this angle 180 minus theta. Let us write this. So magnitude of friction is mg sin theta, mg sin theta. Then displacement delta r is given as speed into time. Cos of 180 minus theta becomes minus cos theta, right? That becomes minus cos theta. Then that minus of course will come here, and then it will become mg sin theta cos theta into dt. Now this we can write as, let us multiply 2 and 2 here. So minus mg by mg vt by 2, and 2 sin theta cos theta can be written as sin 2 theta. So this is the work done by friction. This is the answer for this. Clear? Are you clear about this question? Yes. Well, here you cannot say that friction is mu times normal. Suppose if you write friction as mu times normal, you should not write it mu times normal. Can you tell me why? Friction should not be written as mu times normal. Why? Can we write friction as mu times normal? Why? So the friction which is acting right now is static friction, but we do not know whether that static friction is maximum static or not. If it is just going to slide, then you can use this maximum static mu times normal. Okay, but body is not sliding; it is just at rest, but it has a tendency of motion. So body is rest. That means right now static, but that static can also be maximum, but it is right now not maximum because body is relatively not moving. Clear? Body is not moving. Yes. Any doubt? Hmm. 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 How do you know how much percentage loss? So that's why suppose if you take friction as a constant friction, right? Constant friction. Now I think your question is a good question. Uh, I have assumed friction as a constant friction, right? Your question is very good question, right? I think by assuming friction direction as constant, we are making a mistake here. You're right. This we have made a mistake. We have made a mistake because assuming friction, assuming friction as constant is mistake. Can you say why it is mistake? Let us say friction is constant, but its magnitude is constant. Try to understand. You have raised a very good point. Friction has to act opposite of velocity, right? And if you see here, the bomb which you have released here, let us say friction magnitude is constant. But because this is going in a circular motion, and let us say at an instant right now it has a velocity in this manner, at this instant its velocity this manner. So friction has to act opposite of this velocity. Very good question, very nice question. Suppose the body comes here, then body will be moving in this way, its velocity will be tangential. So now friction direction will change now, right? Now friction direction will be opposite of this. Are you understanding that? Yes. Yes. So now what mistake we can correct this mistake, instead of taking just f into h, you have to do integration here. Just correct this step. Okay. This step we have to correct. So work done by work energy theorem only, work done by mg plus work done by friction is equal to change of kinetic energy. We can calculate that loss. Okay. So final kinetic energy minus initial kinetic energy. Initial kinetic energy is 0, that we know because it is released. Final kinetic energy will write as half mg square. Now work done by mg, definitely mg is constant, so mg is always acting vertical. There is no doubt in this. Mg is always acting vertical, and this height is nothing but the length of this bomb. So this work done by mgh or mgl, that is right. But work done by friction, you have to take care, because friction is always changing. So you have to take a dot product integration f dot dr, you have to do. Okay, f dot dr. Now what is integration of f dot dr? First we try to understand what is integration of f dot, because friction is always opposite of displacement, and dr is like instantaneous displacement. Dr is like instantaneous displacement which is happening in this forward direction, in the direction of velocity, dr, and friction is opposite. So friction and dr is making 180-degree angle. Okay, so when you open this, you will write f, you will write dr, and you will write cos 180-degree, because friction and instantaneous displacement are opposite. So now it will become minus integration f dr. Now friction magnitude is constant, you will take out of integration of now dr. Now integration of dr is a very good important thing. Integration of dr means you are adding dr, 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 dr. Now tell me how much will be this length. Quickly tell me how much is this length. Aha, this is the path length. This is the distance. Remember, I told this also previously. In case of friction, you should take the distance, because friction is a variable force. Length of the path you have to take. So this length is radius, or this length is LL, and this is 90 degrees. So this angle theta, radian you have to write pi by 2. So this arc length become theta into L. You know that this arc length is pi by 2 into L. So this length dr integration is the length of this path. So you have to write this as minus friction into pi L by 2. Now you will substitute here and so on. Very good point here based. This mgl minus f pi L by 2 is half mv square. Then you calculate from here v. So v square will become 2 by m mgl minus f pi L by 2. So now you can divide this and take that. So v will become root under 2, mass I will take inside, L I will take common. So it will become g minus pi f by 2. L I have taken common, pi f by 2. This will be the final speed. You don't have to bother about loss. Loss automatically you can calculate, because you know the final speed. See, loss is happening. Why? Loss is happening because of friction, right now. Yes, loss is happening because of friction. So if they ask what, if they ask what is the loss, if they ask loss of energy, loss of total energy, that is nothing but magnitude of work done by friction. Because friction will do negative. Negative means that is what is loss. So work done by friction, you have calculated this now. You take magnitude f by 2 pi L. This is the loss that is happening. If you have to calculate percentage loss if you want to calculate, so whatever the loss divided by original total energy into 100, you have to do initial. So then you can calculate. So percentage loss also can be calculated. So f by 2 pi L, original energy was only mgh, total energy mgh means mgl into 100. So from here L will get cancelled. So f pi by 2 mg into 100. This will be the percentage loss of energy. Clear? Yes. Done. Any other doubt if you have asked? Okay, so I hope this class will helping you, because here you can ask any type of question in the class. Also, you can ask any type of question. Anywhere you meet me, you can ask any type of question. Okay, related to your studies. Okay, done. Then let us find out, then we'll see. So I will create today some test, okay? Some test I will create that you can write tomorrow at any convenient time, okay? Hmm. Hmm. It is happening weekly, like 3 days, Monday, Wednesday, and some Friday. I have planned, but previously it was going on night, but I have shifted it to early, like 7:30 to 8:30 evening. Okay, because night it is better to take rest and wake up early morning. It is good for health and concentration, focus, right? So I have shifted the class early. Night time you also should take rest early so that you can wake up early. So make a proper schedules. Okay. So recorded classes are available. Don't worry, recorded classes will be available. You can watch it anytime. But if you want to attend this weekly, you can attend 7:30 to 8:30, 3 days. And I will be updating the time in the group also. Okay. Saturday every week not able. Today I was available, so I have taken this special class. Okay. But any doubts are there that we can always discuss it. Okay, and we'll be able to help out. Otherwise also some other ways, but other weekdays we are having this. But Sunday, if you have Sunday, if many students have doubt for Sunday, I can also take for 1 hour, maybe in afternoon or something. Okay. Okay, then we'll see. Bye bye, all the best for you, and do write the test. Okay? Thank you. Bye.